Okay, good morning, good afternoon, class. All right. Alhamdulillah. So at this point, you guys have written a test. Sure, most of you got full marks for that, no? Sorry, I couldn't have made it a bit. I couldn't have made it more difficult than that. Okay. So this work is simple. Simple mathematics. Alright, so we spoke about did I give you homework? This I gave you for homework, no? Right. Then you had to do the third one. So firstly we're going to convert this to be in the form of ax to the exponent e. Not so. Is it in that form currently? No. So what you're going to do is you're going to convert this to exponential form, so it's d of x. And there's of course a 2, so it's x5 over 2. You all agree with that? Now I can apply my derivative. Once I apply my derivative here, I drop the d. Not so? The derivative of x, now I'm deriving. So that is simply going to be 5 over 2, x to the derivative. You all agree with that? Okay? Look at the next one. Can I apply the derivative to the sum here as it is here? No. So what do I need to do? At that time of the day, acting up again. Don't want to play along? Yes? But upper. Okay. So we can't derive as a standing there, not so. So what we do is I factorize the numerator. So I can simplify it first. So it's d of x. This is your trinomial. X minus 6. Numerator you got x minus 6 definitely. Into x plus 1. So what happens? Cancels, not so. So it's the derivative of x plus 1. Can I apply the derivative now? Yes. Derivative of x is 1. The derivative of a constant is 0. Is there any confusion here? You all understand, eh? Right. This one here, is this in the simplified form? Yes. I can apply the derivative as it stands here. So this would be what? ds over dt, the derivative of s with respect to t. Derive the first term, what do I get? Negative 10 t plus 3. Okay, you all okay with that? Alright. You mustn't be right. Wasn't this supposed to have been your homework? Yo, no, why are you writing down? You didn't attempt it for homework, my girl. Huh? Which page are we on? Page 154. Page 154. Let's check for me on page 154 in example 1. Determine using the rules of differentiation. What does that first sum read there? I don't think this is right like it is. Does it read f prime x equals f of x? F prime x, if f of x equals 7x squared minus 5x plus 4h. Or is it this plus 4? Plus 4. Then h is not there. So that h mustn't be here. So what I want you guys to do is to apply the derivative. So apply the derivative quickly. Okay, so if I apply my derivative, what do I get? F prime x equals 14x minus 5. Derivative of a constant is 0. What does that 14x minus 5 mean? Okay, there we all go quiet again. Yes, a general gradient anywhere along the curve. A general gradient anywhere along the curve. Here's the next one. Determine using first the rules of differentiation. dy over dx if y is equal to 3x squared minus 9x minus 2. Derive that quickly. That's reading. So differentiate this. Once we apply the differentiation, rules of differentiation, you then say dy over dx equals 2 times 3 is 6x, right? 6x to the 1 minus 9. Derivative of a constant is 0. You all okay with that? So anybody that's confused? Is number 3. Can I apply the derivative like it stands here? What do we have to do first? Multiply it out, okay? Doesn't sound like you are saying that, but I think you are saying that, no? Alright, so what do we need to do first? Multiply out. So we get 2x squared minus x minus 6 is minus 7x plus 3. You all agree with that? So what do I do now? Apply the derivative. So what do I write here? dy over dx equals 2, ne? So it's 4x minus 7. You all okay with that? Right. Next one. Can I apply the derivative as it stands there? No. I need to simplify. Okay? In the numerator, I'm going to take the trinomial, difference of two squares, and trinomial factorization. And the denominator, what can we do there? Common factor of x. So do that quickly. Here we got d of x minus 4, x plus 3. You all agree with that? Over x as a common factor, and then left with x plus 3. Now what? What can happen? X plus 3 cancels. So I'm left with d of x minus 4 over x. Which is the same as, so I'm going to simplify this now, x and x. Each one of its own. Why? So that I can get it in the form of ax to the exponent n. That simplifies a bit. That cancels, the 1 minus, and this I need to bring up, 4x minus 1. Can I apply the derivative like it stands there? Yes. So apply the derivative. Okay, so once I apply my derivative, I drop this d. Not so. So what do we have? Apply the derivative. Derivative of a constant is 0, so that is gone. Negative 1 times negative 4 is 4. If I subtract 1 from that exponent, what do I get? X minus, which is 4 over x squared if you want to write it with positive exponent. You all okay with that? Any confusion? Number 5. Can I apply the derivative like it is there? No. So we got a trinomial of a monomial. 3 terms over 1. So what can I do here? We'll write each one over its own. Not so? And then simplify it from there. So it's x cubed over x squared minus 2x squared over x squared plus. Now the square root of the x can be written as what? X to the exponent 1 over 2. Not so? That's over x squared. Simplify. So this gives us the derivative with respect to x. That gives us x minus 2 plus. When you're dividing and pieces out the same way, subtract the exponents. Half minus 2 is negative 3 over 2. You all agree with that? Any confusion here? Okay, can I apply the derivative now? Can I apply the derivative now? Yes. Let's apply the derivative. It will be 1 times 1 is 1. Minus 1 is 0. Derivative of a constant is 0. Negative 3 over 2 times 1 is negative 3 over 2. X, if I minus 1 from that, what do I get? Minus 5 over. Okay. Any confusion? This one here. Right, so this means x cubed over x squared, so it's x. Not so. So there's d over dx, no? So that cancels that, leave you a negative 2 plus. Now when bases are the same and I'm dividing and subtract the exponent. So it's a half minus 2, which is negative 3 over 2, or negative 1 and a half. Okay. And as you can see here, it's in the form of a x to the exponent n. Now I can apply my derivative. When I apply the derivative, that gets dropped. There's a 1 and a 1, so that gives you 1. Minus 1 is going to be x to the 0, which is 1 anyway. That's a constant, so that falls away. Negative 3 over 2 times 1 is negative 3 over 2. X, let's subtract 1 from that, I get then negative 5 over. You understand?
Yes,
okay. Number 6. So what needs to be done first? With the brackets, not so? Alright, so what do we get? S is equal to, we must multiply this out. We must first get it in the form of ax to the exponent n. Okay, I must get it in simplified form. So it will be t to the half times t to the 3 over 2. When you multiply and base are the same, we add the exponents. So we'll get t to the 2. Not so? Plus t to the half times 2 is 2t to the half. Negative 3 times t to the 3 over 2 is negative 3t, 3 over 2. Negative 3 times 2 is negative 6. You all agree with that? Can I apply the derivative now? Yes. So what do I say here? D is over dt is equal to. Apply the derivative, what do we get? 2t to the exponent 1. Not so? So 2t to the exponent 1 plus half times 2 is 1 minus 1 gives us t to the minus 1. Negative 3 times 3 over 2 is negative 9 over 2. T minus 1 half. And it's a constant, it falls over. Alright? You guys understand? See any confusion there, people? Now you see here in exercise 6, there are 28 sums. Are you excited that you got so many of this? Yes, okay, but I'm not going to fulfill your excitement today. I'm only going to give you half of it to do, okay? Sorry about that. Because I will only be able to do half in tomorrow's lesson, okay? Alright, so for homework you're going to do from exercise 6 first column. Or exercise 6 the odd numbers, okay? You guys can start with it now. If you have any problems, we can discuss it. Otherwise I'll stop the video at this point as well, okay? Alright? People, don't waste your time. Are you guys finished with this work already? Yes? Then do the work. Don't have your own conversation, huh?